So today we'll be talking about correlation coefficient. Under the correlation coefficient are three subtopics. What is the Pearson product moment correlation, its formula, and some examples. Correlation coefficient. This is used in statistics to measure how strong a relationship is between two variables. You can see in the right side of the screen different graphs, which we'll talk about later on. On the left side of the screen, you can see the formula and the interpretation. This is where we would base how high or low the correlation is between the variables. So correlation coefficient formula. Formulas return a value between -1 and 1, where 1 to 1 indicates perfect correlation, positive to negative 0.75 to positive negative 0.99 indicates high correlation, positive negative 0.51 to positive negative 0.74 indicates moderately high correlation, positive negative 0.31 to positive negative 0.50 indicates moderately low correlation, positive negative 0.01 to positive negative 0.30 indicates low correlation, and 0 indicates no correlation. So, correlation coefficient of 1 or positive correlation means that for every positive increase in one variable, there's a positive increase of a fixed proportion in the other. For example, a shoe size go up in perfect correlation with foot size, So that's a graph. It's going up. That's a positive correlation. Next is correlation coefficient of -1 or negative correlation. Means that for every positive increase in one variable, there's a negative decrease of a fixed proportion in the other. For example, gas in tank decreases in perfect correlation with speed, so it's going down. Negative correlation. 0 or no correlation means that for every increase, there is no positive or negative increase. The two are just not related. Just one straight horizontal line. So Pearson product moment correlation, or the PPMC. This shows linear relationship between two sets of data. Two letters are used to represent the Pearson correlation, the Greek letter rho for a population and R for a sample. So here's the formula. R is equal to n times the summation of xy minus the summation of x times the summation of y, divided by the square root of open bracket n times the summation of x squared minus open parenthesis summation of x close parenthesis squared, then close bracket, times open bracket, n times the summation of y squared minus open parenthesis, summation of y, close parenthesis, square, then close bracket, where n is the number of pairs of scores, summation of xy, sum of the products of paired scores, summation of x, the sum of x scores, summation of y, the sum of y scores, summation of x squared is the sum of squared x scores, summation of y squared equals sum of squared y scores. Then here's first example. Find the value of the correlation coefficient from the following table. So here we have subject, age, and glucose level. The subject represents the N, the age represents the X, and the glucose level represents the Y. First, you have to multiply the X and Y, the XY, multiply age and the glucose level for the XY. So 43 times 99 is 4,257. Then just multiply the others. To get the X squared, square the X. So 43 squared is 1,849. Then so on and so forth. To get the Y squared, square the Y. So 99 times 99, or just by itself, square, is equals to 9,801. Then we have the summation of xy. To get that, add all the numbers in the column under xy. So it's equals to 20,485. Same with the x squared, add all the numbers, and we have 11,409. So with the y squared, 40,022. Same with the x, summation of x, just add just add all the numbers under the column. So we have 247, same with the y, 486. And count how many numbers are there. So there's 6. Your n is 6. Here we have the solution. So first is what to do is substitute the values. So here, substitute the values. And then what to do next is square whatever it needed. Square whatever numbers that have to be squared. And then you have the answer. Type it in the calculator and then press enter or equals answer. And there you have the answer. 0.53. Always round off the second decimal place. This kind of method, when you input in some calculators, it gives a different answer or sometimes syntax error. So be sure to know your calculator. So it doesn't apply to all. We have a step-by-step method to accurately find the answer. It takes quite some time, but it's safer, and you can see where you would go wrong in the solution. So here's another example. Find the value of the correlation coefficient from the following table. So we have math and science. The math represents the x and the science represents the y. Do the steps again, multiply x and y. So 20 times 17 is 340. Then just multiply the others. To get the x squared, square the x. So 20 squared is 400 and so on and so forth. To get the y squared, square the y. So 17 squared is equals to 209. Then we have the summation of xy. To get that, add all the numbers under the column xy, and then it equals to 1794. Same with the other summations, add the numbers in each column. So we have the numbers under x squared, we have 2100. Numbers under y squared, it's 1528. Under x, 141, and under y, 118. Then count how many numbers all in all, and that's your n. So there are 10 numbers, or n is 10. So here's the step-by-step solution. We have the formula, and then substitute the values. Next is multiply 10 times 1794 and multiply 141 and 118. Square 141 and then 118. So we have the answer to that. Next is subtract 17,940 and 16,638. Then subtract also 21,190 and 19,881 and 15,280 and 13,924. So here's the answer, a simplified answer. Then you still have to simplify that. Multiply 1,309 and 1,356. So that's your answer, 1,775,004. Then find the square root of 1,775,004, and we have 1,332.29, or the whole long equation or whatever. Then what to do is you can just stop at the second decimal place, or if you want it very accurate, you can write it all. Then divide 1,302 to 1,332.29. Then the answer, just round off to the two decimal places, and then you have your answer, 0.98. 0.98. That answer is already round off, so always remember to round off to two decimal places. So for the next example, instead of using pen and paper, we will use computers, or more like the software, to solve for the PPMC. So if you want to solve using the computer, or maybe you're doing research or whatever purpose, the software we'll use is the Microsoft Excel. It's very easy and convenient, unlike the two methods, since it takes a lot of time. So we have another example. So under A is biology, and under B is chemistry. What to do is, in another cell, in the small rectangular boxes here, type the equal sign and all capital letters, type Pearson. Then open parenthesis. Since the first given is under capital letter A, that's the letter we will use. So A, and then look at the number where your first given is in. So in this case, 2. So A2, then colon, no space, then find where the last given is placed. In this case, A9. Do the same for the other given. So the final formula is equal sign, all capital letters, Pearson, open parenthesis, A2, colon, A9, comma, B2, colon, B9, and then close parenthesis. Then, just press enter, and we have the answer. Round off to 2 decimal places, and final answer is 0.72. Simple as that. You can solve it manually to prove that that's the answer. Try the other examples in Excel if it's the same answer to the manually solved one. Thank you for listening to this presentation. I hope you learned something.